Good morning, students. It is class 12, chapter number 9, lecture number 9. In this lecture, we will discuss about the simple microscope when image forms at infinity. After that, we will discuss about the compound microscope. So first, I am taking simple microscope when image forms at infinity. In previous lecture, we discussed simple microscope when image forms at a distinct vision point. In this case, we will discuss when image forms at infinity. It is a convex lens. It is its principal axis, optical center C. It is its focus. If object will be a chord F, in that case image will be formed at infinity, so object is placed at there. Object A. So ray which is parallel to principal axis will pass through focus. Ray which is passing through optical center will be undirected. So these two rays will be parallel. If I extend, they will meet at infinity. Now we will find out what will be its angular magnification. This distance is the distinct vision point. So if I take same height, the size of the object will be equal to this much. Suppose I say it is A prime, B prime. If I join this B prime to the C, this angle is alpha. Angle of object with I when object is placed at a distinct vision point. And this complete angle, this angle is beta. Whether image is at this point or at this point, this angle will remain beta. So when image is at a distinct vision point and object is also a distinct vision point, then alpha and beta are the angles with I. Now we know that angular magnification is tangent beta upon tangent alpha. And because these angles are very small angles, so tangent beta will be equal to beta and tangent alpha will be equal to alpha. So it will be equal to beta by alpha. Now tangent alpha will be equal to, this angle is alpha, so it will be A prime B prime upon A prime C. So tangent alpha will be A prime B prime upon A prime C. Now tangent beta. Tangent beta will be this side upon this side, that is AB upon FC. So tangent beta will be AB upon FC. Now we will calculate its magnification. So magnification will be tangent beta, which is AB upon FC into, it is divided by tangent alpha, so it will become A prime C upon A prime B prime. But A prime B prime height is equal to AB. So there it will be cancelled, so it will be equal to A prime C upon FC. A prime C, it is a distinct vision point. A prime C, distinct vision point, FC focal length. So it will be B upon F. So if image forms at infinity, in that case, angular magnification will be D by F. So that will be the angular magnification of a simple microscope when image forms at infinity. Now we will discuss compound microscope. Compound microscope. We will take first case when image forms a distinct vision point. Generally in compound microscopes, the image is focused at a distinct vision point. So first of all, its construction. This is one lens, convex lens. This lens is called object lens, denoted by LO, O for object. It is its principal axis. I am extending it in both sides. Its aperture size is small and its focal length is also very small. Suppose I say its focus FO, O for object. Object is placed just beyond FO. Suppose this is our object. AB is object. Optical center C1. So almost same length. So ray which is parallel to principal axis will pass through F, and ray which is passing through optical center will be undeviated. So its image will be formed here. A prime, B prime. Inverted and magnified image. After that we will take second lens. Second lens is placed here. This lens is called eyepiece, LE. And we adjust this distance so that its focus FE. This image forms between optical center C2 and FE. Image due to first lens, that is object lens, should be between focal length of the eyepiece and its optical center C2. If object, so it will behave like object for this lens. A prime, B prime will be object for this eyepiece lens, and this object is between F and C. So erect image will be formed, magnified, erect, virtual, and it will be in same side. So this is focal length. Now ray which is parallel to principal axis will pass through F, and ray which is passing to optical center will be undeviated. So in this side the distance is increasing. So if I extend these lines, they will appear to meet at this point. So image will be formed at this point. It is final image. This point is suppose A double prime and it is B double prime. AB was the object. A prime B prime is the image due to object length, and A double prime B double prime is virtual image due to eyepiece. This is the final image. Our eye is here. So that is due to that region it is called eyepiece. So this is the angle between image and eye. So that will be called beta. And this image is forming at a distinct vision point. This distance is d. Now angular magnification, it is the ratio of angle between image to eye when both are image to eye and object to eye when both are at a distinct vision point. This image, it is distinct vision point. If I put this object here, I am assuming, actually it is not put here, I am assuming same height. Now join it with C2. So this angle will be alpha. Suppose I say this point is, I am taking this point as B. So P A double prime is equal to AB. Now we want to find out what will be its angular magnification. That was the ray diagram. Now we will calculate angular magnification. Before that, I want to explain that aperture size of object length was small, focal length was also small. For eyepiece, comparatively aperture size will be large, focal length will be small for eyepiece as well. Now, angular magnification is beta by alpha, or you can say it will be equal to tangent beta upon tangent alpha. Now we will substitute the value of tangent beta and tangent alpha. Tangent beta. Tangent beta is A double prime B double prime divided by A double prime C2. Height upon base. So it is A double prime B double prime upon A double prime C2. So tangent alpha. Tangent alpha will be A double prime P divided by A double prime C. So magnification will be A double prime B double prime divided by A double prime C2 into A double prime C2 divided by A double prime B. So A double prime C2 will be cancelled. It will be equal to A double prime B double prime divided by A double prime P, but A double prime P is equal to AB. So divided by B. Now I am multiplying this equation by A prime B prime and dividing by C. A prime B prime divided by B prime B prime. It is multiplied and divided by same factor. This m will be equal to, now I am rearranging these two terms together and remaining two terms together. That is a prime b prime upon ab into a double prime b double prime upon a prime b prime. A prime b prime by ab. A prime b prime by ab. Size of image to size of object due to object length. So that will be linear magnification due to object length, MO, or for object. Now A double prime B double prime by A prime B prime. Image due to eyepiece divided by size of object due to eyepiece. That is linear magnification due to eyepiece. We know in lenses magnification is V by U. Linear magnification is V by U. We have already discussed. So for object lens, it will be VE. Suppose this distance is VE, distance between lens and image formed due to this object lens. So it will be VE divided by UE. This distance is UE into ME, linear magnification due to eyepiece. Image is forming a distinct vision point, so that will be D upon this distance between this image and this lens. Because this image is object for this lens, so this distance is sorry, that was UO, not U. So that will be U. Because it was object, so U. D upon this distance is UE. So D upon U. Now we will simplify this part, D upon U. We will simplify this. Now we will focus on this part. We know lens formula is minus 1 upon U plus 1 by V is equal to 1 by F. For this eyepiece, distance is UE and this distance is a negative, so minus minus it will become plus 1 upon UE. Image is forming a distinct vision point and that is also negative, so it will be minus 1 by D. Is equal to 1 upon its focal length is FP, so 1 by F. Our aim is to calculate D by UE, so I will multiply this equation by D. So D upon UE minus 1 will be equal to D upon FP. So D by UD will be equal to 1 plus D by F. Now we know the value of D by UE. Now we will substitute that value in this equation. So what will magnification? magnification will be, that was also VO upon UO into D upon UE. D by UE is 1 plus D by F. 1 plus D by F. This image is forming at this point. So this distance is VO. That distance was VO, and this image is very close to this lens, and its focal, because its focal length is very, very small, so this distance is negligible. It is very, very small, so this distance will be negligible. So VO will be almost equal to distance between object lens and eyepiece, that is this distance. Suppose that distance is L. So this distance is L, and it will be positive, divided by this distance. This object is placed just beyond focal length, so this distance is almost equal to focal length, so it will be FO, and sign will be negative, so it will be minus L by FO, 1 plus D by F. So that will be angular magnification due to a compound microscope. If FO and FP will be small, then M will be large. So focal length of eyepiece and object should be small, then angular magnification will be large. That was about the compound microscope when image forms a distinct vision point. In previous topic we discussed about the light maker's formula. I will take that small topic. And we discussed if we immerse the lens in any liquid, then its focal length changes. Lens maker's formula was 1 by F is equal to mu minus 1 by R1 minus 1 by R. We say generally convex lens is converging lens and concave lens is diverging lens. But it is not always. Convex lens can behave like a diverging and concave can behave like a converging. Under which condition? Suppose there is a lens having refractive index mu z, and it is, suppose I say this is the lens. Its refractive index is mu z, and it is immersed in some liquid having refractive index mu L for liquid. And I am assuming that mu L is greater than mu z. Mu L is greater than mu z. So what will be the relative refractive index? Refractive index of this lens with respect to this liquid will be equal to mu z by mu L. So 1 by F will be equal to mu z by mu L minus 1 by R1 minus 1 by R. This is first surface, its center will be this side. This surface, second one, this is first, this is second, center will be this side. So R1 will be positive, R2 will be negative. So negative and negative, this term will become positive. So for convex lens, this term will be positive. For convex lens, that term will always be positive. Now I am assuming that mu L is greater than mu Z. That is mu Z is smaller. It means this term will be less than 1. So this total term will become negative. So focal length will be negative. And if focal length is negative, then it will be concave lens. That is why we can prove it by derivative part. Otherwise, you can explain it using Ray diagram as well. This is the convex lens. Its center C1 in this side, its center C2 in this side. This is the incident ray parallel to principal axis. Refractive index mu L, refractive index mu Z, and we are assuming that mu L is greater than mu Z. At this point, draw perpendicular, so join it with the center, that will be perpendicular. This is the perpendicular. Now it is moving from denser to rarer medium. That was its path. Denser to rarer, it will bend away from the node. So it will bend in this direction. It will bend away from the node. Now at this surface, now it moves from this medium to this medium, that is from rarer to denser. At this point again draw perpendicular. Join it with the center. That was the path. Now it is moving from rarer to denser, so it will bend towards the normal, so it will bend in this direction. So it will bend in this direction. So there will be double bending away from the principal axis. So this convex lens will behave like a diverging lens under this condition. Otherwise, generally convex lens is a converging lens. Similarly, you can try yourself. If instead of this convex lens, if we take concave lens, then what will happen? That concave lens will behave like a converging lens under same condition. So that was about the compound microscope and how lenses behave if they are immersed in some liquid. Thank you.